Okay, so today what we're going to look at is the sum of the interior angles of a triangle. So specifically what we want to know is what's angle 1 plus 2 plus 3. But first, let's look at these. So angle 4 plus angle 5 plus angle 3. If we look at that, those three angles create a straight line. So these three added together have to equal 180 because it makes a straight line. Okay, now the question becomes, how does angle 4 compare to angle 1? So if we look at angle 4 and angle 1, those are alternate interior angles because they make this nice little Z shape. And since this line is parallel to this line, it means that angle 4 is congruent to angle 1. So congruent, and then alternate interior angles with parallel lines. All right, then let's look at angle 2 and angle 5. So angle 2 and angle 5. So if you look at angle 2 and angle 5, those are also alternate interior angles, so they have to be congruent as well. So for the exact same reason, angle 2 is congruent to angle 5. Same reason as angle 1 and angle 4. Now, the question becomes, why does the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equal 180 degrees, which is what we claim the interior angles of a triangle add up to? Well, first off, let's start with the first statement. And remember, our first statement came from up here and said that angle 4 plus 5 plus 3 should equal 180 degrees because it's a straight line. Now, let's look at this. Angle 1 has to be the same as angle 4, so what we can do is just replace measure of angle 4 with measure of angle 1. And now, also, angle 2 is the same as angle 5, so we can replace angle 5 with the measure of angle 2, and then we can just leave the measure of angle 3 where it is, and that equals 180 degrees. Now there's another informal proof made by Mary Pardo, who was a math teacher, said one of her students came up with this idea. It's gained a lot of popularity recently as to why the angles of a triangle add up to 180. And basically it starts with an arrow. And an arrow starting at the vertex for angle A and pointing that way. Then you rotate the arrow up. So you rotate it as many degrees as angle A, and it goes to right here. Makes sense? Then you rotate the arrow again, but you rotate it by the number of degrees in angle B. So if you rotate it this way, the end of that's going to go down there, the point will stay up here, and there we go, we have it right here. And then the last part, you rotate it the same degrees as angle C. It goes down there and there. So the key here is when you start with this, it's facing like kind of down and to the right, but after you rotate it all three of these angles, it's facing the exact opposite direction, or 180 degrees different from the way it started.